This is section 6.2, example number 3. A linear equation in 3 variables is an equation equivalent to one of the form ax plus by plus cz equals d, where a, b, c, and d are real numbers, and a, b, and c are not zero. A solution of a system of 3 equations in 3 variables is an ordered triple that makes all 3 equations true. For example, 4, 0, negative 3 is the solution of the system below. We can verify this by substituting 4 for x, 0 for y, and negative 3 for z in each. So let's go look at example 3 and how we solve a solution. I'm going to give you a step-by-step process to follow while you're doing this. So I'll start with step 1. Step 1 is to choose any 2 equations and eliminate one of the variables. Okay, so I'm going to choose for this problem, I'm going to take these first 2. So I'm going to choose the x plus 3y equals 2z equals 9, and the x minus y plus 3z equals 16. Now I want to eliminate one variable. It doesn't matter which one. I'm going to go ahead and eliminate the x. So I'm going to multiply this bottom equation by a negative 1. So that's going to give me a negative x plus y minus 3z equals a negative 16. Then I'm going to bring that top equation down underneath it. X plus 3y plus 2z equals 9, and I'm going to add those together. Now when I do that, the x is eliminated. And that was the purpose of step 1. So that gives us, we add those together, 4y minus z equals a negative 7. Now I'm going to circle that because I need it later. All right, let's go to step 2. So for step 2, choose a different 2 equations and eliminate the same variable. Now, it's important that it's the same variable, not a different variable. It is very important that it's the same variable. It doesn't matter which 2 you choose. I'm going to pick the bottom 2. So that's going to give me x minus y plus 3z equals 16. And then 3x minus 4y plus 2z equals 28. Now I've got to eliminate the exact same variable. I can't eliminate a different one, so I'm going to take that top equation and multiply it by a negative 3. And when I do that, I'm going to write the answer underneath here. So I get a negative 3x plus 3y minus 9z equals a negative 48. Now I add those 2 together, and notice what I eliminate is that x again. You've got to eliminate the same variable. It doesn't matter which one as long as you eliminate the same one. All right, that leaves us with a negative y minus 7z equals a negative 20. And circle that equation. Now we're going to take those 2 equations that we circled for step 3, and we're going to solve step 3 like it's a normal system, just like we did in the last section. So this is step 3. So now I'm going to take the two equations that I have circled. I'm going to highlight them now, this one and this one. I'm going to set them underneath each other. So I get 4y minus z equals a negative 7. And I get a negative y minus 7z equals a negative 20. So this is my whole new system. So now you're going to do this just like you did the problems that were in section 6.1. So I'm going to take that bottom equation and I'm going to multiply it by 4. So I'm going to multiply this bottom equation by 4. And that gives me negative 4y minus 28z equals a negative 80. Then I'm going to add that to the top equation, which is 4y minus z equals negative 7, and add those together. Notice this time that the y cancels out. So I get negative 29z equals negative 87, and I divide both sides by a negative 29 and get z equals 3. So I have z. And step 4, the last step, I'm out of room, so I'm just going to tell it to you, is you substitute that 3 back in to find y, and then you're going to take both of those and substitute it into one of the beginning equations to find z. So here we go. 4y, I'm taking that top equation. I'll highlight it so you can tell which one I'm taking. I'm taking this top equation again, the 4y minus the 7z, and I'm plugging in 3 for z. So I get 4y minus 3 equals a negative 7. Add 3 to both sides, and I get 4y equals a negative 4. Divide both sides by 4, and I get y equals negative 1. All right, so now I have my y value. Now I choose any one of the original equations. It doesn't matter which one, any one of the 3 original equations. I'm going to choose this one because it looks the simplest, but it doesn't matter which one you choose. And I'm going to take that equation, I'm going to substitute in my z is 3 and my y is negative 1. So I get x minus y, which is minus negative 1, which makes it plus 1, plus 2 times 3, which is 6, and that's supposed to equal 16. So I get x plus 7 equals 16. And then subtract 7 from both sides, and I get x equals 9. Let me see if I did that right. I got x plus 1 plus 2 times 3, which is 6. Nope, it's not 6. That's my mistake right there. So this is supposed to be a 9. That makes this a 10, and that means x equals 6. Sorry about that. And there's my x. And then you give the answer as an ordered triple, and an ordered triple goes in alphabetical order, x, y, z. If you put them in the wrong order, they'll be wrong. So x is 6, y is negative 1, and z is 3, and there's the answer.